Whenever a major aviation incident occurs, the entire world holds its breath for one specific item: the black box. News anchors and investigators discuss it with deep mystery, leaving millions to imagine a dark, pitch-black secret cube hidden deep within the plane's structure. But if you ever stood inside an active crash investigation site, you would realize something shocking. The famous black box is absolutely not black. It is not even a box. In fact, it is a heavy, metallic cylinder painted in a brilliant, blinding shade of fluorescent neon orange. So, why do we call it a black box? And why did aviation engineers choose the brightest color in human physics to paint it? The story behind the name takes us back to the dawn of modern computing and military secrecy. In the 1940s and 50s, early flight recording prototypes were highly classified military technology. In the world of science and physics, any complex device with hidden internal mechanics was abstractly referred to as a black box. Furthermore, the earliest models actually utilized light-sensitive photographic film to record instrument data. To prevent sunlight from instantly destroying the film, the entire housing had to be painted matte black and sealed in total darkness. By the time Australian scientist David Warren invented the modern magnetic tape flight recorder in 1953, the mysterious nickname had already stuck permanently in media culture. However, as commercial aviation expanded, engineers quickly realized that finding a matte black object in the aftermath of a catastrophic plane crash was a literal needle-in-a-haystack nightmare. In 1965, international aviation authorities enforced a strict new rule. All flight recorders must be coated in a specific shade of high-visibility paint known as international orange. In the physics of light wavelengths, this exact fluorescent shade offers the highest possible visual contrast against almost any natural background. Whether the device is buried under deep green jungle canopies, submerged in the dark blue depths of the ocean, or surrounded by charred black volcanic ash, international orange instantly pops out to the human eye. To maximize its survival rate, engineers also moved the device out of the cockpit and hid it inside the airplane's tail section, which statistically suffers the least impact damage. But what happens if the flight recorder ends up miles below the ocean surface where sunlight cannot reach, and even the brightest neon paint becomes completely invisible in the pitch blackness? For this extreme scenario, engineers added a brilliant electronic layer of tracking. Mounted directly to the outside of the orange cylinder is a specialized device called an underwater locator beacon. The moment this beacon touches water, it automatically activates and begins broadcasting an acoustic ping at 37.5 kHz. This high-frequency sound wave can travel through miles of crushing ocean water, allowing naval sonar systems to track the device from the surface. This silent electronic distress signal pulses once every second, powered by a rugged internal battery that lasts for 30 consecutive days. To ensure the neon orange paint survives to be found, the underlying structure must be virtually indestructible. The modern flight data recorder is a masterpiece of extreme survival engineering. The delicate internal memory chips are encased in a solid block of liquid silicone, wrapped in a thick layer of high-temperature thermal insulation, and sealed inside a heavy, solid forged titanium or stainless steel armor shell. Before any black box is approved for a commercial airplane, it must survive a brutal series of laboratory trials. It is blasted out of air cannons to simulate high-speed impacts, baked in industrial ovens at over 1100 degrees Celsius, crushed under hydraulic presses, applying thousands of pounds of pressure, and submerged in pressurized deep-sea tanks. It is built to survive the absolute worst conditions human technology can experience. Ultimately, the device we call the black box is the ultimate safety oracle of the modern sky. It preserves the valuable data that allows engineers to understand mistakes, rewrite safety regulations, and prevent future accidents from ever happening again. It is a silent, brilliant piece of invisible engineering dressed in neon paint, designed to protect every single life that steps on a plane. If you love uncovering the surprising histories and hidden technology behind the simple things around us, make sure to smash that like button and subscribe to the channel for more deep dives.